Welcome everyone. Thank you very much indeed for joining us this afternoon for this, the latest in our series of webinars which mark the coming to an end of the ITRC Mistral research program. We've had 4 webinars so far. This one is the 5th, which have looked at a whole series of different aspects of the ITRC's research, and we have 2 more coming up in our series, which I'll refer to again at the end of the webinar. The Infrastructure Transitions Research Consortium has been working with support from the Engineering and Physical Sciences Research Council for almost 10 years, developing new systems, modeling and methodologies for national infrastructure systems decision making. And one of the most important aspects of that has been our work on risk and resilience of infrastructure networks. So in particular, understanding the potential scale of climate related hazards to infrastructure networks, though not only climate related. This afternoon we're going to hear about security-related threats and space weather as other threats to infrastructure systems. And we've developed really quite unique now capabilities for modeling the interdependencies between infrastructure networks, between energy, transport, water, digital infrastructure, for doing that on broad scales, at a national scale, and now at a global scale, looking at the links between infrastructure network failure and supply chains, and the economic impacts of infrastructure failure at a macro scale, and then using that information to prioritize adaptation interventions and promote resilience within infrastructure networks. And there's really a unique capability which has been developed around all of those aspects of infrastructure network risk and resilience analysis. It's been very widely taken up. First, we were called upon to input to the National Resilience Review. We did analysis for the Department for Transport, for the Environment Agency's long-term investment strategies, and we're here from Mike Steele about that work this afternoon. And then for the National Infrastructure Commission's recent infrastructure resilience study, and then at global scales for the World Bank, the Global Commission on Adaptation, and most recently as part of the Coalition for Climate Resilient Investments. And we'll hear from Carlos Sánchez this afternoon about that work. So please, during these webinars, use your social media. The format will be that we will have a presentation from 2 ITRC speakers, from Raghav Pant within the University of Oxford, and from Dr. Edward Oughton, who is now at George Mason University, formerly part of the ITRC team in the UK at the Universities of Cambridge and Oxford. And then we will have some remarks and feedback from Mike Steele, who is the Flood and Coastal Risk Management Expert Advisor at the Environment Agency, and Carlos Sánchez from Willis Towers Watson, who's playing an absolutely central role within the Coalition for Climate Resilient Investments and Finance. As we go through those talks, please use the chat to pose your questions. You can start posing those questions as soon as we get going. And once we've had our talks, we will open up the discussion and I will chair the questions which you post in the chats. So please keep going, start with your questions straight away and keep going with them as we go through the talk so that we have a good discussion when we get to the end. And within these webinars, we will definitely finish by 1/4 depending on how the discussion goes. And we've had very lively discussion at all of our previous webinars. We'll probably keep on going a bit past the hour, but we'll definitely be done by 1/4. So before I go any further, it's a great pleasure to welcome Dr. Raghav Pant to provide an overview of the infrastructure risk and resilience analysis which we have done within the ITRC program. And I will stop sharing my slides now and hand over to Raghav.
Thank you very much, Jim, and thank you very much for everybody who's attended. And I will start sharing my screen without further ado. I hope, I was having some problems in the practice. I hope it works. Let's see. Yeah, so I hope everybody can see my slides. And yeah, welcome to this presentation, which is about risk and resilience of infrastructures, which I'm going to present with Ed. And I apologize in advance that there's a lot of things to cover in these slides. So it'll be a quick whistle-stop tour of a lot of studies. And before you adjust to understanding one study, we'll probably move on to the other one. But please bear with us. If anything, you have any confusions or questions, please ask them. And also, I've left email IDs of people at the bottom east slide who are the lead authors of these studies, and you can contact them. What is this whole resilience modeling or resilience challenge that we have been addressing within ITRC? The infrastructures that we are looking at, the electricity, the transport, the water, the waste, the telecommunication systems, they exist as networks. And in these networks, you have a failure. And once a failure occurs at a local asset level, the failure has a propagation effect or a cascading effect, which causes disruptions, which are much wider scale towards businesses, towards households, towards populations. And then there's an even wider scale of impacts which are felt across supply chains and across the economy. And in order to unpack all these kind of different types of effects that are taking place, we get asked these questions in all our studies, that how do we quantify these network vulnerabilities and risks? And this question of direct and indirect economic impact is a very crucial one in understanding these vulnerabilities and risks, because mostly people concentrate on the direct aspect of an asset losing its value, but the whole understanding of an indirect economic effect associated with infrastructure assets is something that we have done a lot of work on, and we have tried to respond to this question. Then what follows from an understanding of vulnerabilities and risks is the question of then how do we respond to them? How do we build resilience interventions and policies to reduce those vulnerabilities of critical infrastructure assets? And of course, in a large-scale system like an infrastructure asset, a national-scale infrastructure, you can't invest everywhere. You can't avoid every impact. So the question always is on how do we prioritize those investments, resilient investments, so that we can get the maximum out of our limited budgets that we have. Moving on, in order to respond to these challenges, what we have done is we have created a framework, which we call the System Systems Framework. It's not an original word that comes from us, but the System Systems Framework is like this, that first of all, infrastructures do exist as interdependent, interconnected networks of multiple layers, and they are interacting at these multiple layers with each other. And in order to model these different layers and their interactions, we built something called process-based network models, where we will look at, for example, in the slide that you see the kind of bit of a graphic from the UK, try to understand the whole like multimodal system of transport, of roads, of railways, of airports, ports, and how do they interact with each other. Similar models are built for electricity, for telecommunications, other systems as well. We try to understand their interactions with people, with the population, with the users in space and time. And then we model the interactions of all these systems with the businesses, households, and the governments at a more macro scale. So in building this process-based model, what you start already seeing that if something happens at one layer, at one level, you will start seeing that interactions at every level and every layer will have a cascade towards them, and then you will see these cascading effects that we try to quantify. And our philosophy of building these large-scale models is also to do a whole ensemble simulation of multiple failure conditions and multiple failure events, driven by either an external hazard or even simple kind of man-made impacts or security-based issues. And what we try to quantify is the whole kind of ensemble of different failure scenarios, and doing an exhaustive stress testing. We try to see different risk outcomes under different probabilities of events happening and different failure outcomes. And finally, we kind of look at the with all this information, we look at how the risk information then can be integrated with optioneering and with kind of understanding different options of investments over time, and looking at their costs and benefits and their economic impacts, and looking at which infrastructure asset or economic sector to invest in, to prioritize in. So moving on from this, from example, the basis of our work mainly is underpinned by demonstration. We are a very kind of show and tell kind of a group where we demonstrate things with as real data as we can. So for example, in the UK, where we have done a lot of studies, we have assembled a national scale database of electricity, telecoms, water, rail, and road networks. And as you see in this slide, for example, the electricity network is a multi-layered system that goes all the way from the generation side of things all the way towards the transmission and the different levels of distribution depending on the voltages of the substations, and all the way up to the customers. Similar a representation of the telecoms network, for example, the open reach network that we have tried to model and visualize over here, goes all the way from the high level core network to the macro cell networks, which goes all the way towards the buildings. And in the case of all of these networks, we try to also kind of map their linkages or dependencies and interdependencies with each other. We've done a lot of work on railways, for example, in detail, where we have kind of looked at the railway infrastructure network and seen how the railway is connected to the electricity, telecoms, gas, and other systems through assets such as the traction system, the point heating, signaling connections, and other kind of assets that you expect in a typical railway network. And I will now move on to some demonstrable evidence that has come out of all these studies. So one of the first studies that we have over here in the UK context is looking at flood risks to inform investments. And the main message over here through all of this network modeling is this evaluation of direct and indirect risks. So what you see over here in the graph is a study that was done on looking at flood risks to electricity, water, wastewater, and gas infrastructure assets, and how these assets as services were affecting residential and non-residential buildings. And also further looking at how electricity disruptions will add further disruptions, which you see in green, to water, wastewater, and gas networks, which are dependent on electricity. And what this does is it adds an extra layer of information on saying that there is a whole world of indirect flood risks that have not been estimated in the previous Environment Agency long-term investment planning. And now with this information, it strengthens the case for investing in flood protection, because previously when you were just doing direct damages and direct effects, your case for avoided risks was much lower. But now with having an understanding of indirect risks, one of the key results which came out of the study was that the benefit cost ratio of investing in flood defenses, in flood protection, went from 5-to-1 towards 9-to-1, which is a kind of a very crucial finding. An interesting study that we did for the National Infrastructure Commission this year looked at tracking failures and interdependencies, how they propagate and cascade across infrastructure networks. So we looked at some 18,000 cases of failures on the UK's electricity networks, the data that I showed you 2 slides prior. And we looked at if like an experiment of simulating failures of assets on these networks. And from there, we looked at how many of these failures cascaded further to other networks of telecoms, water, and railways. And were there cases of the disruptions feeding back or cascading back into the electricity network? And further on, how much of this forward and backward feedback or feed forward loop was happening again and again till we could kind of see a stabilization of cascading effects. And it was a very interesting result that we found from the study, is that almost 60% of failure events of electricity networks led to telecoms network failures, which further led to electricity network failures, which further led to telecom network failures. And then there was further electricity. There was a whole chain of events. And for example, in this Sankey diagram that you see, the railway failures, like most of those railway failures happen not with the initiating electricity network failures, but after a second or third or fourth order effect that is of failures going back and forth between electricity and telecoms networks before they kind of start affecting the railway networks. And this was kind of very interesting, kind of understanding the overall picture of cascade interdependencies and their role in failure cascades across networks. We did this, I mean, another experiment we did with the NIC was just saying that in all the interdependencies that we have mapped, if we add another level of redundancy between networks, like add one more connection between each interdependent layer, so we see that this 59% failure cascade effect actually is dramatically reduced to only 5.6% failure cascade effect. And this was just a kind of an experiment to give an idea of what is the effect of just increasing the robustness of these national scale networks. We didn't go into the case of building the economic case for doing that, but it was worth investigating in this instance. I'll pass the control to my colleague Ed Oughton pretty quickly to go over some cyber physical risk studies that he has done. Ed, it's over to you.
Thank you, Raghav. Hello, ladies and gentlemen. In this piece of work, we essentially applied the system of systems models that Raghav just spoke about to actually understanding cyber risks. So essentially, we had an electricity model, and we were able to cycle through different substation combinations in order to understand how many people could be affected by different sized cyber attacks. And this work was actually initially started thanks to sponsorship by Lockheed Martin. And we produced a white paper on the left-hand side when I was postdoc at the Centre for Risk Studies at Cambridge. And we eventually published the work in Risk Analysis, so the journal on the right-hand side here. So we feel like this is an exciting area of research. There's been lots done on natural threats to infrastructure, but not so much done on the cyber physical perspectives. Next slide, please, Raghav. Thank you. So this was also a very new area to us, and essentially we started doing some assessment of space weather risks to infrastructure, and we were then asked to carry out a UK assessment. So we developed a probabilistic model which was able to link together the space physics to the geophysics on the Earth, to the electrical engineering component in the extra high voltage electricity network, and then link that through to the disruptions on the ground to people, businesses, and the macroeconomic impact. This provided some really nice information, so we're able to look at the probability of failure of substations based on the different scenario sizes. So you can see that on the right-hand side here. So even up to 1 in 10,000 year events. So that sounds like a very improbable event, but the wave that breached the wall at the Fukushima nuclear power plant was designed for a 1 in 10,000 year event. So we wanted to push the analysis in that type of direction to look at the extremes. So that was the first nice piece of information that we got out, the actual potential probability of failure, but we also got the macroeconomic impact as well. And we were able to publish that in Risk Analysis, and we were very happy to actually win a Best Paper Award for that work. So that was a collaborative effort essentially between Cambridge and Oxford, ITRC essentially, with the British Antarctic Survey, British Geological Survey, STFC, Airbus. And that work was picked up in some quite prestigious popular science places as well. So Scientific American, Natural Geographic, and Wired were just some of those outlets that covered this piece of analysis. And it fed on to us doing more work in other locations, including feeding into the Canadian Space Agency's assessment of space weather risks in Canada. Next slide, please. So this was the space weather risk assessment piece that we did for the USA. It was actually the first piece that we did, and it was a white paper which we produced with funding from AIG, so American International Group, and it was very much focused on the insurance implications, essentially, of infrastructure asset failure due to space weather. And from this work, which we did collaboratively, essentially we were able to get this paper produced, which we submitted to the AGU Space Weather journal, which actually had quite a decent amount of impact. So you can see some of the outputs that we were able to produce on the right-hand side here. So different types of blackout zones from space weather events that knocked out electricity assets led to different direct and indirect customer disruptions, and we were able to quantify that. And actually, it got picked up in some news outlets as well, so including USA Today, Bloomberg, and also Sky News. Thank you.
Thank you very much for that, Ed. And I will now just move on to talking exclusively of work that was done on transport infrastructure. So we have covered electricity, we have covered telecoms, and we've covered all this interdependency work that was done for all these different infrastructures in the UK, and one study with Ed's presence in the US. So we've done a lot of transport studies as well. And it starts with kind of this global scale assessment study, that's a remarkable piece of work which my colleague Elko Cox, who was with us, but is now assistant professor at the Free University of Amsterdam. He did this whole study of global scale analysis of looking at roads and railway infrastructure networks across, well, the whole world essentially, and looking at the risks to these, the exposure and the risks to these due to extreme winds, earthquakes, surface flooding, river flooding, and coastal flooding. And what the study presented was like a first piece of evidence of direct risks of assets in terms of damages to value of assets of roads and railways when exposed to these different hazards. And you can see kind of this whole picture of the whole world, and you can kind of identify hotspots of these exposures and risks. And you can see which kind of countries, whether they are based on income level, how much they are affected. And one interesting insight that came out of this study was that about 27% of global roads and railway assets are exposed to one or the other hazards, which is kind of not surprising. But it's what is kind of very interesting is giving a sense of the scale of these impacts. And the study showed that the expected annual damages, like the amount of the damages every year for roads and railway assets due to these multi-hazard events, are between 3.1 to 22 billion US dollars, which is a substantial range and a substantial figure. So this was kind of a very interesting insights, which and first piece of evidence at the global scale that was done for infrastructure networks. And what what Elko's study does is it highlights this whole picture of direct impacts, which is what is the standard in most of the risk studies, which is what the insurance companies also kind of try to kind of understand when they think about financial investments. What is the exposed value of assets? What it's kind of missing these kind of studies is this whole idea of indirect impacts, which I was kind of talking about before as well. But in transport, it's a very crucial to look at these indirect impacts, and we have done some of that at national scale studies, because doing a whole global scale study is still out of scope, but we are working on it. But we've worked in different countries with the World Bank, in Tanzania and Vietnam and Argentina. And the idea over here is to map these transport networks in detail, and also map freight flows along the important corridors and national scale routes, and even local roads, and like every possible road we can find on, try to map freight along these routes and try to understand that if there are disruptions to freight flows along these routes, what are the economic impacts? So what you see in this slide are 3 maps, and each map kind of shows a kind of similar information. Is that the roads which are the highlighted the most, the colors which you see the most highlighted in each map, simply shows the economic value associated with that, with the disruption of that particular segment or that particular route of the network. And you see that they are kind of, in the case of something like Vietnam and Argentina, our models estimate up to like a 1.9 million economic losses per day of important freight that could be accrued in these countries. And this is kind of a very important message, because what it does is it kind of helps in building the case for investing. And this investment also is very much contingent on the speed of how you invest, because indirect economic impacts are very much driven by the duration of disruption. The longer a disruption lasts, the bigger the impacts keep on getting. And in our studies, we've tried to bring out this point, and through two examples over here that I'm showing. Like if you look at the graph on the left, the first graph, what you see is like looking at road segments in Argentina and looking at the direct and indirect damages associated with them. The direct damages are the colors in light red, which kind of show that there's a lot of direct impacts if you look at them initially. But then as the duration of disruption goes on increasing from 10 days to 20 days to 30 days, you see this whole kind of indirect effects which far dominate the direct effects. And this means that there are certain road segments in the country that might not be of high, but that might not see high direct impacts, but the economic indirect impacts due to the disruption are immense. And this has an effect in also building the case for investment, because the longer the graph on the right shows that at least in the case of Argentina, the case for investing in climate resilience in Argentina is very sensitive to how long the duration of disruption is, rather than projections of GDP growth or other kind of factors which also influence economic impacts. And this is kind of a very important message that comes out of our study. And where we are taking all of this is in terms of kind of finally understanding and giving a message to stakeholders or planners on how to build this case of costing climate resilience and where to prioritize. And what you see over here with this work in Argentina is where all this analysis really leads to is finding the benefits, which is the avoided risk, all the risk assessment and risk calculations of direct, indirect that we do at the network level, and assign them to individual sections and routes of the network, and say that this is the risks associated with this asset, and these are the benefits of avoiding. So the benefits are avoiding those risks. And then we have also looked at some sort of resilient options of building kind of climate resilient roads and how much investment is needed for each road. And if you compare the benefits and the costs of climate resilience investment, then you can do a benefit cost ratio calculation to simply kind of get a map of where you should prioritize, where the biggest, highest, and you should prioritize based on the highest benefit cost ratios. So this has been a very useful information for transport planners in Argentina who have kind of are using it as I speak for kind of understanding where to prioritize their investments based on budgets as well. And this is the final slide that I have. What kind of the message that I want from this for you from this talk is that the value of all the work that we do is towards creating a scientific evidence for understanding risks in networks systematically. And we want to provide this. We are no way claiming that our analysis gives you the right result or is the right analysis. There are of course a lot of gaps with data, with modeling assumptions and everything, but we believe that it's at least provide the first order of evidence to prioritize and screen your assets for resilience building activities. And we built this tool in Argentina, web-based interactive tool, which is what we are doing more and more of nowadays, of helping people to pretty much kind of zoom in on the map of their country, click on their roads or other infrastructure assets, and kind of get all these different kind of metrics of risk and investments and their cost benefit analysis. And this helps these transport investors to understand the magnitudes of contributions that are required, the nationally determined contributions towards meeting their Paris targets. This is what was the question that was posed for us when we did one of these studies in Vietnam and Argentina. And at the end of the day, I mean, all this is key for providing evidence for disaster risk finance, which has become a very important thing. And I think one of our respondents will talk about more of things that are being done in that front. And with that, I would like to end, and thank you very much for listening, and thanks for the opportunity. Over to you, Jim.
Thank you very much indeed, Raghav and Ed. That's an incredible amount of information about some extremely impressive and really groundbreaking work there. We've now got 65 participants and a whole bunch of questions coming into the chat, so please keep those coming. We'll pick them up in the discussion. And actually one or two we might wish to pick up in our respondents' remarks straight away, because we've had a question, including from Sue James, about links to decision making, to land use planning. That might be something that Mike picks up in his remarks in a moment. And also questions around stakeholder engagement in collecting data and in the decision-making process. But let's not run ahead of ourselves. It's a great pleasure to welcome first Mike Steele from the Environment Agency, who's really responsible for the Environment Agency's long-term investment scenario planning. And as Raghav mentioned in his presentation, the work we've been doing on the potential impacts of flooding on infrastructure systems has become factored into that analysis. So over to you, Mike.
Thanks very much, Jim. Yes, I just wanted to say a little bit more about the infrastructure impacts analysis, which informed our long-term investment scenarios. So our long-term investment scenarios it's an economic analysis which estimates costs and benefits of investing in flood and coastal risk management in England in a number of different future scenarios, looking forwards 50 to 100 years. And this is used by government and others to inform policy and investment choices. Now, within LTIS, we've always tried to include or indirect impacts to things that aren't just standard properties. We've only been able to do that in quite a simple way in the past. So previously, we've factored up property impacts based on previous major floods, particularly 2007 floods, to estimate non-property impacts and some of these indirect impacts. But in particular, the Cumbria floods of 2015-16, that winter, they showed some really significant impacts both to transport and utilities. So there were over 200 bridges damaged, and some of them just clean washed away. The East Coast main line was closed. A591 was closed, and there were some great case studies, or rather very interesting case studies of the impacts of loss of electricity to Lancaster and other places. So after those floods, the question was, are we estimating these indirect impacts well enough? Are they potentially non-linear when you get these very widespread flooding where whole communities are cut off from all directions? So we work with the ITRC to understand these transport and utility infrastructure impacts better, not just the impacts to the sites, but to the networks and the dependencies. So for the first time, we're able to quantify, as Raghav showed earlier, the number of properties which don't just get wet carpets, but which suffer other impacts. So they lose services or they lose connections via road or rail networks. And so from that work, we could see that over 60% of properties, and it's pretty much 2/3, they're served by infrastructure sites and networks which are located in or dependent on others located in areas at risk of flooding. So that changes our narrative pretty significantly from previously talking about 1 in 6 properties at risk of flooding to talking about over half properties in England potentially being impacted indirectly by flooding. We also learned a lot about the importance of duration of flooding, as came up in the Argentina example, and other sensitivities to estimating these impacts. So in terms of the results, they didn't actually change significantly our estimate of the magnitude of the impacts, but they gave us a much better appreciation of the potential range and the sensitivities and more confidence in the figures that we were getting from that simple uplift. So we're able to represent these damages better within the calculations. As mentioned earlier, that increased some of the headline results. The benefit cost ratio overall increased from 5 to 1 up to 9 to 1, and that strengthened our case for investments particularly early this year for budget 2020. Looking forwards, the new flood and coastal risk management strategy came out recently with a vision for a nation resilient to flooding and coastal change, and a specific ambition about infrastructure resilience in tomorrow's climate. And just one key thing related to that, I mean, that strategy is going to drive both the new set of long-term investment scenarios, but also a new national flood risk assessment. And that national flood risk assessment will include, for the first time, duration of flooding information, which will enable us to do far better infrastructure impact assessments in the future. Back to you.
Thanks very much indeed, Mike. And I mean, this is has been a journey of interaction between our research program and the Environment Agency for many years now. And I think it's a great example of how research is feeding into really important decision making at a national and indeed now at more local scales. So thanks very much indeed for that, Mike. I now hand over to Carlos from Willis Towers Watson, who brings the international perspective and the finance sector perspective on these climate risks to infrastructure, which Raghav has been presenting. Over.
Hello, Jim, and thank you very much for the invitation, and thank you everyone. And congratulations for the fantastic work. It's simply impressive and really a privilege to work with this group. So thank you, Raghav and Ed, for the great presentation. I think that on these brief remarks, what I would like to focus is where Jim kind of introduced me to, that is around the topic of finance and why institutional investors are very, very interested in this topic and what is the application and the value for them. And to explain that, I'm also going to present the Coalition for Climate Resilient Investment that Jim referred to. Oxford is part of it, and also the Environment Agency is actually co-chairing this initiative. And it's basically an initiative that brings together the global private finance industry with a commitment to really advance practical solutions that guide investment decision making in the way that we better price physical climate risk in those. So we have 6 institutions with 10 trillion of US assets represented. And basically we have 3 areas of work. One that is at the systemic level, where mostly I'm gonna be focusing now. And that is really helping public decision makers to prioritize where the most economic and social value in a given jurisdiction, in a given time horizon is at risk. So at the heart of the topic of this webinar today, the other area of work is at the asset level, and it's basically trying to integrate the appropriate climate risk analytics into cash flow modeling, the design and the structuring of individual projects. And the other is on financial innovation, really trying to catalyze the innovative capacity of the financial industry to not only raise capital for resilient investments, but also that capital drives the appropriate pricing of physical climate risk. But again, and in the interest of time, I would like to focus on the fantastic value of what's being presented today for this whole mandate. And that is that both institutional investors and governments recognize that there is an undisclosed and unmeasured a volume of economic and social value that is at risk in given jurisdictions, in given time horizons. And because of that, we have an inefficient allocation of capital, both from the national level, but also at the private level. And that is what the coalition is trying to address, and that is what the solutions that we've been presenting today, today, are really helping to change the narrative there. And how they're changing them, I think that what Raghav has just presented really showcases how we can bring science into a real practical decision making, in the sense that we can start to prioritize and understand what are those top locations within a given infrastructure network and within a given jurisdiction, again, where that economic and social value is at risk, so that we can facilitate public decision making in the sense of how every dollar of fiscal resources maximizes the protection of that economic and social value, but also has a strong linkage to private capital, because private capital also requires a proper case for a jurisdiction to sustain economic value and to produce those cash flow models. So certainly the work that actually developed by Oxford within the coalition, we're having discussions with now about 6 jurisdictions where we are in advanced discussions about developing this tool. Every jurisdiction has a particular need, and this is something that Jim and Raghav will be better placed to speak about the peculiarities of that. But it is true that it's something that is common in both OECD and non-OECD jurisdictions. We would expect that this would only be exclusive to emerging and frontier economies, but certainly we see that too in developed economies. And it is true that the deployment of these analytics will be tailored to the preferences and to some extent the risk appetite of decision makers. But what we really need, and what is being brought up here, is a consistent approach to understanding how those networks sustain value and how those indirect impacts, ripple effects, really bring that indirect nature of exposure to climate risk. So certainly really exciting and fantastic to be working with this group, and very keen to share more information. But maybe Jim, now in the interest of time, let me stop there, but happy to address any other question. Thank you.
Thank you very much indeed, Carlos. And one point I would also emphasize is how the Coalition for Climate Resilient Investments is a really central part of the build up to COP26 in Glasgow next November, that mobilizing the finance sector and then creating genuine difference on the ground with respect to climate resilience is very much part of the UK government's approach with respect to COP26, and the initiatives that our group is involved in with Carlos at the moment, developing really functioning tools and methodologies which will be part of the package for COP26. So thanks again, Carlos, for that. And let's now go to the discussion. Thanks very much indeed, everyone, for posting your questions. We've got a lot of questions. I'm going to take them in groups and share them around, and please keep them coming. And the first cluster of questions is around data, inevitably. This is always a big question for such a data-intensive modeling activity. And I think I will pitch a number of questions at Raghav, if I may, and then give Raghav an opportunity to respond to those before we go on to the next ones. We have a question from Sue James about the availability of the mapping data. I think that was with reference to the UK data, but you might wish to comment on the international and global data as well. A question from Arturo Casal on the level of granularity of the infrastructure data, in particular with respect to the water infrastructure, but you might wish to comment on, Raghav, on the varying spatial granularities that we have. And a question from Simon Hodgkinson about stakeholder engagement in data collection, which I think also links up with Chris's question, and this is the last of the four we'll take in this round, which is to do with asset condition, a very good and tricky question around how one actually collects valid data, not just about the location and dimensions and design of data of infrastructure, but also about its physical condition, which is such a key determinant of its reliability. So over to you, Raghav, to take those questions.
Thanks for those questions, Jim, and yeah, I'll try to answer them. Yeah, I mean, data is always the question, the number one question. I'm not surprised that questions on data have come up. So first of all, when it comes to most of the data that we try to create, especially the stuff that we've done in the UK, we try to rely on open source data as much as possible. For transport, I guess Ordnance Service open data resources are quite good, and they do kind of give you very good information, detailed information that we've built on railways. We actually did have some data and connections with Network Rail previously, and now we have actually even better connections with Network Rail, because one of the PhD or DPhil students here in Oxford, Ohis, is seconded with Network Rail. He has already worked for 10 years in Network Rail, so he's developing a very detailed interdependent model for railways for us, which is based on exact Network Rail data that Network Rail has. So in some ways, we have kind of, because of over the years that we've done this work in the UK for the last almost 10 years, we have been able to build stakeholder relationships and trust for them to give us some of the data. But in some, and it depends on sector to sector. I mean, and that is what also influences the spatial granularity of these networks. If I come to that point, getting information on water assets at very detailed spatial scales is something that we have struggled with. That is why we have a national scale water model at a very high level. And I think it was very well picked up that the spatial granularity of the water system seemed a little bit higher than all the other networks. Telecoms has also been a kind of a bit of a challenge. That's why we showed you the model on which was only the open reach network. Of course, there are lots of private networks. We kind of struggle to get data on that, but we try to do our best as we can. With the NIC study that we did, one of the advantages of working with the NIC, the National Infrastructure Commission, for those who don't know, was that we had a lot of stakeholder engagements with companies and regulators and organizations like DFT, who were happy to give us insights on maybe not exactly the data, but insights on what kind of interdependencies do matter between different infrastructure networks. And that in itself was a kind of a clue to fill in some data gaps. And yeah, that comes to the point of stakeholder engagement as well. I mean, through all of these studies that we've done, we have constantly tried to kind of have conversations and involvement of stakeholders and get their inputs regarding, in many cases, what are the key interdependencies that matter? What are the risks from one infrastructure on another, which they think about the most? What kind of systems within their infrastructure networks do they think of in terms of being most exposed to different kinds of risk? And it's a constant process of kind of stakeholder engagement and evolution of these models. The stakeholder engagement in the international studies with the World Bank has also been crucial. One of the things that we've done with all the studies that I spoke about, the transport studies with the World Bank, we have, in a way, we have been kind of contracted in those studies by the ministries of transport in those countries, who have been very engaged and interested. So many times they have given us information. And there's a bit of, of course, you go from country to country. Tanzania was an initial kind of proof of concept study for us, and getting data over there was much difficult. Vietnam and Argentina, we got some very good information from the ministries of transport over there. And things like asset conditions and information within these countries were very well compiled by the ministries of transport, but only, I would say, at the level. So within, again, coming out to the whole hierarchy of networks, transport networks, if you think of their hierarchy, they have the national highways, the motorways, the big primary roads, and then you have the secondary and the tertiary roads. So asset information by the national transport department is generally, the data collection is much better at the national trunk road, primary road level and it gets worse and worse actually at the secondary and the tertiary level. But then we have had conversations with them on how to kind of build some, if data is not there, how to fill those gaps with just some generalized understanding of what these asset conditions and things like that would be. That's it. Thanks, Tim.
That's great. Thanks very much indeed, Raghav, for addressing those perennial questions around data. I'm going to move to Ed next, because we have a question from Ash Gupta about electromagnetic pulses. And I think that the question in part is are we now, given that there are some technologies to protect against them, are we evaluating the benefits of those technologies? Does there need to be more regulatory intervention to promote the appropriate uptake of technologies to protect systems against electromagnetic pulses? I hope I've got that right, Ash.
I'm afraid that we didn't include EMP within our study because it's been looked at before. With space weather, it's a bit of an unknown one hitherto, and that's why we ended up focusing on that. But I think you're right, though, that there are operational changes that can be made in the network, and there are ways that you can enhance the resilience of assets. So within the space weather context, there has been quite a bit of regulatory change now. At least in the US, but it's been mainly standards focused, okay? So there have been requirements put on electricity asset owners, which means that they have to upgrade their assets to a certain standard so that they can withstand a certain amount of additional load that's placed on them. I think also there's a greater understanding now of the operational changes that can be made to the network, which can help to avoid sensitive components being destroyed, at least from the space weather impacts. So for example, it was actually different depending on the country which we analysed. In the UK, they basically turn all of the assets on and aim to spread the extra electrical current that's generated across the whole network, because that way it prevents any individual components being exposed. So there were these different options for how to increase resilience depending on the network which we studied. And I think there have been some changes that have been implemented. But the problem with all of this work is that you don't have much of a historical record. And the last significant event, for example, that the UK had to deal with was about 30 years ago. And the network's changed a lot since then. So there's a big unknown as to how the network assets overall are going to respond if there was a significant event.
Great, thanks for that, Ed. I'm going to answer now the question from Rob Jones in the UN Office for Project Services. Great to have you with us, Rob. It's a while since we've met. And you've asked about changing return periods of extreme climatic events. In relation to cyclones, we know that cyclones are becoming more severe, intense, so we're getting more category 4 and 5 cyclones, and that's what climate models are projecting for the future. The cyclone frequency for the time being seems to be staying more or less the same. But for many of the climatic extremes that we're looking at, like flood risk, the evidence from climate models is really quite uncertain, quite variable. And what that points to is very much a robustness approach, a decision-making under uncertainty approach, so that we're stress testing systems in a very wide range of possible future conditions. We're collecting evidence from climate models about what those possibilities might be, but we're also recognizing the uncertainties. But then looking at that wide range of possible conditions, how the system responds in the way that Raghav has described, and then what might be robust investments and policy interventions in order to manage those risks in a proportionate way. So thanks for that question, Rob. And I'm now going to pass back to Raghav with a couple more questions. The first is from John Steed, who asked about the possibility of using this modeling to look at a scenario where people, operatives, running systems were prevented from coming to work. So the system is not able to operate because some set of operators, maybe in a particular location, are prevented from coming to work. So that's an interesting example, which we might address with the type of modeling that we do. And also a really great and in many senses classic question from Andres Morales about validation of these models of extreme, rare, sometimes previously not seen events, which makes it really difficult to validate. So thank you for that question, Andres. Over to you, Raghav.
Thanks for those questions. And yeah, to respond to the question of John Steed, I mean, yeah, yes, we can do that. We did a study, I didn't cover it over here, but we did a study for the Department for Transport a few years ago called the single point of failure analysis, which looked at failures to transport networks in the context of not just flooding, but in the context of ice, blizzard, and extreme wind conditions as well. And we did kind of explore questions on the lack of accessibility. I mean, the whole idea of the single point of failure was to identify locations which result in the network being cut off from the rest of the system, something like what happened with the Dawlish rail line collapsing into the sea and cutting off the railway network from that part of the country to the rest. So these questions of looking at multiple hazards and looking at accessibility, we have explored, and our models are very well equipped to do that. And responding to the question of Andres, yeah, the question of validation is a very, very good one, and we get these questions all the time. One of the ways of validating is, first of all, again, it comes back to the original question from Simon Hodkins about stakeholder engagement and consultation. One of the ways is to sit with stakeholders and ask them about what kind of cascading effects do they think happen in their infrastructures, and kind of getting a sense of the order of magnitudes of cascades and the order of effects. And some of the there have been some real life cascading effects. For example, the Lancaster electricity substation failure is a very classic example where an electricity substation failed in Lancaster and resulted in a lot of other infrastructure failures, and going all the way to residential and non-residential buildings and knocking off electricity and other supplies for more than 24 hours. And we did the kind of in some of our models, I mean, we did actually get similar where we were able to simulate and model similar side of disruptions with our models, and that was kind of served as a bit of a validation case study to kind of show to stakeholders that this model can simulate these kind of cascading failures that could be validated. With the work that we've done in different countries with the World Bank, especially in Argentina, we had very detailed discussions with the national transport operators over there on whether certain roads that we were saying were flooded and producing all these multimodal impacts were actually true or not, based on their understanding of their networks and the data that they had collected. But yeah, it's always as Jim said, like this probably a lot of this analysis goes into the realms of decision making under deep uncertainty, and this is where it should be done. But validation is something that in bits and pieces is done here and there. Thanks.
Thank you very much indeed for addressing that, Raghav. Mike, we've got a question from Sue James about the extent to which the Environment Agency is looking at natural solutions, natural flood management, as well as engineered solutions. Can you say a few words about that?
Yes, certainly. So yeah, natural solutions, nature-based solutions, natural flood management, already part of what we do. So there's currently a £15 million programme of investment in those, and in the DEFRA's new policy statement, there's a drive to increase those. Within our long-term investment scenarios, we within the last set of analysis, we looked at the potential for those nationally to reduce risk, in particular, the potential for them to keep risk flat in the face of different levels of climate change. It's quite interesting. It's still very much limited by the data. There's a lot of other research going on, which is building that evidence base at the moment, so that next time around, we'd hope to incorporate them in a more sort of integrated way, so that for different places, we can look at how much these nature-based solutions can form part of a suite of a portfolio of activities to manage risk.
Thank you, Mike. And the last question that we have, there's a final opportunity here to fire in questions, but please put those in the chat. But we have a question from Angela about data security, which again is extremely important question that we come across on many occasions. You've spotted, Angela, that a number of aspects of these analyses are potentially security related. And for those things, we've had to adopt practices to make sure that our computer systems are secure. And we've had advice from the National Cybersecurity Center for that. And for those of you who were at the first of these webinars, you will have heard me introduce the Data and Analytics Facility for National Infrastructure, DAFNI. And DAFNI is a large database and computational facility at the Rutherford Appleton Laboratory in Harwell, funded with a £8 million capital grant from EPSRC as part of the UCRIC investments. And DAFNI is a secure data facility. STFC, who run the Harwell site, are very experienced in dealing with data security issues. And so that will become the permanent home at the end of the ITRC program of all of our models and analysis, and is a national platform for infrastructure systems analysis. So those questions about security have been very much part of the design and the motivation for that national facility, DAFNI. There's a few more remarks. Thanks, Kath, for putting up the links to DAFNI in the chat, and an open question from Ash Gupta about electromagnetic pulses. And a remark from Mike in terms of when the National Flood Risk Assessment is coming out. So thanks for all of that. Great discussion. Thank you all. Let me thank our speakers, Raghav, Pant and Ed Oughton. And I should add at this point that though Raghav and Ed were our speakers today, this work, as in all of our work within the ITRC, has been a collaborative activity, and a huge number of scientists, engineers, researchers have contributed to this work. There's almost 100 people have been part of the ITRC program during its life with the support of EPSRC. And so we should add our thanks to those other contributors to this analysis, some of whom I see on the line there. So great to have you colleagues on board with us this afternoon. And thank you again to Mike Steele from the Environment Agency, and Carlos Sánchez from Willis Towers Watson and the Coalition for Climate Resilient Investments. It's been fantastic to have your perspectives on this work this afternoon. I'm just going to share my slides once more to skip back up to remind everyone before we go about the final two webinars in this series. Oops. The next one on the 4th of November will be zooming in on water infrastructure, on water supply infrastructure, and the national scale water systems modeling, which has been done within the ITRC program and indeed other UKRI funded research, and is now being transferred over to the Environment Agency, Ofwat, and the water industry. So we'll have Jean Spencer, formerly of Anglian Water, and Jonathan Dennis from the Environment Agency joining us for that webinar next week. And then the week after, it will be a great pleasure to welcome Ed Oughton back again, because Ed led all of the work on digital infrastructure within the ITRC program. So Ed, with a series of very interesting colleagues from the digital communications sector, will be leading a webinar on full fiber and 5G rollout, both in this country and around the world. So please join us for those two final webinars within our webinar series. And that ends things for today. Thank you very much indeed for joining us. Bye-bye.